In this lesson, we'll be going over static and kinetic friction. First, let's talk about friction in general. If a box was placed on top of a rough surface, and you tried to push this box, and motion was going right, that would mean that friction is going left. When you start to push this box, the applied force would be overpowering the friction force, as the box is accelerating, and friction can't keep up. However, as soon as you stop applying force, friction takes over and slows down the object until it comes to a complete stop. Let's move on to the first half of today's lesson, that being static friction. Let's dissect this. Static kind of means staying still. So taking it one step further, static friction describes the amount of force to start moving an object based on the mass of the object and how rough the surface of the floor is. This can be put into a formula. The force of friction equals mu times m times g. Let's first look at g. G represents the gravitational field. Right now, the planet that we're on is Earth, not Mars, not Jupiter, and not Saturn. The gravitational field of Earth is always going to be 9.81 newtons per kilogram, or 9.81 meters per second squared. M represents the mass of the object. And this last symbol, mu, not to be confused with the jawline exercise, represents the coefficient of friction. For example, a question would say that this box on this surface has a coefficient of friction of 0.5. The greater this coefficient of friction, the greater the mass, and the greater the gravitational field, the more force that will be required to beat the force of friction and begin to start pushing the object. Once the object starts moving, then that's a whole different can of worms. We'll cover that and kinetic friction later in this video. But for now, let's move on to a practice question involving static friction. A crate of physics textbooks weighs 85 kilograms. If you wanted to push this crate, how much force would you need to apply to beat friction, assuming the floor has a coefficient of friction of 0.15? By beating friction, the question is just asking how much force is required to get the crate to start moving. Remembering the formula, force of friction is equal to the coefficient of friction, which is 0.15, multiplied by the mass of 85 kilograms, multiplied by the gravitational field of Earth, which is 9.81 newtons per kilogram. Kilograms then cancel out, and the coefficient of friction doesn't have a variable, so our final answer will be in newtons. And plugging this into our calculator, our final answer is 130 newtons of force, rounding to two significant digits. Moving on, let's take a look at kinetic friction. As we know, the formula for static friction is the force of friction equals mu times mass times gravity. Remembering that these three variables each represent a different part of the situation. The coefficient of friction describes how rough the surface of the floor is. The mass represents how heavy the object is. And the force of Earth's gravity can also be included as well. But when talking about kinetic friction, we're talking about the next step, after someone has already gotten the object to start moving and have beaten the force of friction. That being said, more variables are included in this scenario that we need to utilize in order to make a formula for kinetic friction. One of the new variables is the applied force, as this represents somebody pushing the box while combating friction. And finally, there's also the overall acceleration of the box altogether. Including all these variables, the formula for kinetic friction, mass times acceleration, equals the applied force minus the coefficient of friction times mass times gravity. Let's use this new formula in the next question. A boy and his friends are going tobogganing. Two friends and the toboggan weigh a total of 125 kilograms. The boy pushes his friends with a force of 350 newtons forward. Question A asks, if the ground had a coefficient of friction of 0.12, What is the acceleration of the toboggan? Let's fill in all the information that we are given. We know the mass is 125 kilograms, and then the acceleration is the variable that we were trying to find. The applied force of the push is 350 newtons. The coefficient of friction is 0.12 multiplied by the mass of 125 kilograms multiplied by the gravitational field of Earth, 9.81 newtons per kilogram. Moving on to the next line, kilograms cancel out, so we can multiply these three together and subtract it from this. This gives us 202.85 newtons. Next, we're going to want to divide out this 125 kilograms so that we can isolate for the acceleration, which comes out to be 1.6 meters per second squared, rounding to two significant digits. For question B, I'll keep the question in my calculator. Next, question B asks, how long would it take for them to travel 45 meters if they started from rest? Just listing what we're given, from last question we know that our acceleration is 1.6 meters per second squared. We know that we're traveling 45 meters, so that's our displacement. We know that the initial velocity is 0 meters per second because they started from rest, and the variable that we are looking for is time. The kinematics formula that can help us find time with these variables is displacement equals initial velocity times time plus 1/2 of acceleration times time squared. Plugging in the values that we have, 45 meters equals 0 meters per second times time, which gets canceled out because anything multiplied by 0 is 0, plus 1/2 of our acceleration of 1.6 meters per second squared, multiplied by time squared. Factoring that half into the 1.6 gives us 0.81 meters per second squared. If you keep the full number from your calculator from last question, times time squared. And next we're going to divide out the 0.81 meters per second squared to isolate for time on this side, giving us about 55.46 seconds squared equals time squared. So to find our time, we're going to take the square root of both sides, giving us a final answer for our time as 7.4 seconds, rounding to two significant digits. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well and hope you have a good day.